All right, algebra, this is the second half of the review for the semester test. I'm going to start with number 24, so if you are not on number 24 and you're down here a little further, you can skip ahead in this video. I'm going to kind of go a little fast just to make this as short as possible. So 24, we did this one in class. 30, the square root of 32, do not write that as a decimal. You need to break it down into the two pieces. So you're taking and trying to find in the square root of 32 the numbers that come out as perfect squares. And perfect squares would be like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, then 25, then 36, and 49, and 64, and 81, and 100. Those numbers are what you're looking for to go into 32. Now, 32 can break down into 4 and 8, but 8 will break down even more then, so you want to go with a number that's a little bit bigger, and the bigger number is 16 and 2. And so if we take the square root of 16, that's 4, and the square root of 2 just stays the square root of 2. So 4 square roots of 2, that's how he will break down, okay? 25 is a subtraction one, and we have i's in here, but everything after the minus is going to get distributed. So this will become negative 4 plus 3i. You combine that with 6 plus 2i, and 6 and negative 4 will become 2. 2i and 3i becomes 5i. And that's all that you can do there, okay? The next one is multiply, so we're foiling. So first we're going to take 6 times 3, which is 18. Then 6 times negative 2i is negative 12i. 5i times 3 is positive 15i. And 5i times negative 2i is negative 10i squared, okay? And then we put over here off to the side that I squared is equal to negative 1. So this I squared is negative 1, and when we multiply that by the negative 10, this becomes a positive 10. Okay, and then we can combine 18 and positive 10, which is 28, and then negative 12i plus 15i is a positive 3i. And that's combined there, okay? On 27, we're solving, and we're solving for x, and it says using i's, so we just know that I is going to show up in our answer. So the first thing, let's just subtract the 50 to the other side. So we've got 2x squared equals negative 50, and then divide by 2, and negative 50 divided by 2 is a negative 25. And then if we take the square root of 25 is 5, but the square root of negative 25 is 5i. And then the only other thing that we need is, since we put the square root in there, we need plus and minus, okay? 28 and 29 and 30 and 31, those are all the factoring methods that we've gone over. So when we're factoring, we have the simple trinomial, that is this first one. And when you're breaking it down, you're looking to multiply to get this number, but when you add them, give you this number. And 8, if we're trying to get negative 8, we could do 1 and 8 or 2 and 4. But if we want it to add to be 7, we have to do the 1 and 8 combination. And negative 7, we want the 8 to be negative and the 1 to be positive. So we do x plus 1 and x minus 8. And then if we set x plus 1 equal to 0, we have x equals negative 1. And if we set x minus 8 equal to 0, x equals positive 8. So that's how those break down. And again, these are quadratic functions or parabolas, and so that means they're going to cross at these two places, okay? 29 is a difference of squares, and we break him down still into two bubbles as well. So we take the square root of x squared and the square root of 16. The square root of x squared is x, so we put that here and here, and the square root of 16 is 4 here and here, and one of them is plus and one of them is minus, and then we just set those guys equal to 0. So if x plus 4 equals 0, then x equals negative 4. If x minus 4 equals 0, then x equals positive 4. If you want to write that as x equals plus minus 4, you can do that as well and just have that answer, but however you want to write the answer, as long as you have both positive and negative 4, I am okay with you writing it together like that, okay? The next one, number 30, is a greatest common factor. So in these two pieces, we're going to pull out a 4 and an x. And if we pull out 4x, we're left with x minus 5. And so then we set 4x equal to 0 and x minus 5 equal to 0. Okay, divide by 4, x equals 0, because 0 divided by 4 is 0. And then this guy, x will be equal to positive 5. And that's what he will look like, okay? And then the last one's the doozy. This is a complex trinomial, okay? So the steps for the complex trinomial is to take the first number times the third number, or the a times the c, and 3 times 5 is 15. And then we have factors of 15 are 1 and 15 and, let's see, 3 and 5, okay? But we want numbers that multiply to get 15, we just listed them, that add to get me this number. So add to get me 16. So the combination that I want is going to be that 1 and 15 combination. And I'm going to have both of them be negatives, okay? So when I break this down, the 3x squared is going to stay just 3x squared. This plus 5 is going to stay plus 5, but the 16 is going to break into the two pieces, okay? And let's see, I'm going to put, it doesn't really matter what order you put these in. I'm going to do minus 15x and then minus 1x. Yeah, let's do that. So we're going to use parentheses to group them now, and we are going to pull stuff out of that group. So the first group, I can pull out a 3x, and left over will be x minus 5. And out of the second group, you can kind of notice that this is like negative x plus 5, but I want it to be x minus 5, a positive x minus 5. So I'm going to pull out a negative 1 to flip that to be the opposite sign. So if I pull out a negative 1, I'll be left with x minus 5. And then my final two pieces will be x minus 5. I'm going to yank those guys out. So x minus 5 is one of my pieces, and 3x minus 1 is my other piece. And then I set those two equal to 0. So x minus 5 equals 0. That means x equals positive 5. And 3x minus 1 equals 0. I add the 1 over. So 3x equals 1 and divide by 3. So x is 1/3. And again, those are the two places where they are crossing. Okay. Moving on, let's go down to 32. They want us to find the value of c that makes this a perfect square. So I want this to be a trinomial, basically, and still we're doing multiply to get this number, and I add to get this number, okay? So we're breaking this down. So we have lots of combinations that will add up to give me 18, like 1 and 17, or 2 and 16, or let's say like 8 and 10. But I want a combination that is the same number, right? So we're going to use the 9, 9 combination. So this will be x, and since it's a positive 18, we'll do x plus 9 and x plus 9. So that I can write this as x plus 9 squared. I want to be able to do this. This is what they're asking me for the answer. Write the trinomial as a perfect square. That's what they're doing here, okay? And then we have to find the value of c. So if we're doing x plus 9 times x plus 9, 9 plus 9 will give me 18, but 9 times 9 will give me this number, and that's 81. So that's the value of c that I get, okay? If at any point in time I'm going too fast, please pause this so that you can back up and get stuff written down, okay? So 33, find the value of the discriminant. 34, we're going to kind of do at the same time. They said use the quadratic formula, okay? So I'm gonna write down the quadratic formula on 34 first. That is negative b plus minus square root b squared minus 4ac all over 2a. Okay, that's our quadratic formula. All right, now the discriminant, if we pop back up to 33, the discriminant is just this part that's inside of the quadratic formula. So b squared minus 4ac. It's just whatever under that square root. Okay, so we're going to calculate that b squared minus 4ac. And we're going to get A, B, and C. And A, B, and C from this is 1 and 4 and negative 32, okay? So B squared is 4 squared minus 4 times, I should put parentheses around that, 4 times 1 times negative 32. And 4 squared is 16. 4 times 32, and two negatives make a positive, so that's 128. So I have 16 plus 128, which is 144, and that is the value of the discriminant, okay? Now, we've done before, we've talked about the discriminant before, where if your discriminant is 0, that means you have one solution. If your discriminant is negative, then that means you have no solutions because you can't take the square root of a negative. And if your discriminant is positive, then you have two solutions. So in this problem, we will have two solutions. Because our discriminant is 144, we will have two solutions, okay? All right, now on 34, they're asking us to actually calculate the quadratic formula and get those two solutions, okay? So we've calculated the b squared minus 4ac already, and we want to go ahead and just do the rest of it, okay? So negative b will be negative 4. We're pulling the same numbers from up here, okay? Negative b will be negative 4. Plus and minus the square root of 144. We've already calculated that number, all over 2 times a, which is 1, okay? Now, the square root of 144 comes out nicely. It is 12. All over 2 times 1 is 2. And then we go ahead and, let me plug my computer in here. There we go. Then, since 12 came out as a nice number, we can split it into two pieces and solve those two pieces, okay? If 12 didn't come out as a nice number, if it was still a square root, we could just go ahead and leave our answer like that. But let's go ahead and solve. We'll do negative 4 plus 12 divided by 2, and then we've got to do the minus. So negative 4 minus 12 divided by 2, so that we have both the plus and the minus, okay? And negative 4 plus 12 is 8, which divided by 2 is 4. That's one of our answers. And then negative 4 minus 12 is negative 16. Divided by 2 is negative 8. So that's my second answer. Again, we said we had two solutions. We just found those two solutions. So we're good to go. Okay? All right. Last chapter is chapter 4. And so I think this is the last chapter. Yeah, last chapter. We've only got a couple left. Write the simplest polynomial function that has zeros that are 5 and negative 2. Okay, so I'm going to zoom in over here. When it says my zeros are 5 and negative 2, that means x equals 5 and x equals negative 2, okay? Then we work backwards and we say, like, what did they look like in the bubbles, right? Well, we know that they're the opposite signs, so x minus 5 and x plus 2. And then from there, all we do is just FOIL, right? So x times x is x squared. X times 2 is plus 2x. Negative 5 times x is minus 5x. And negative 5 times 2 is negative 10. Okay, then we put stuff together, those middle two pieces will become x squared minus 3x minus 10. And that's my, my FOIL. So that is a polynomial that has zeros that are 5 and negative 2. Okay, all right, let's move on and let's do 36, which is another multiply, but instead of doing FOIL, this is 2 pieces times 3 pieces. Oop, times 3 pieces, there we go. 3 pieces, which is going to give us 6 pieces total. 2, 3, 4, 5, 6. Okay, so x times x squared is x to the third power. X times negative 2x is negative 2x squared. X times negative 3 is negative 3x. And then we go to the negative 2. We're going to distribute him through. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is a positive 4x, and negative 2 times negative 3 is a positive 6. And then we just combine like terms, okay? So x cubed can't go with anybody, so we'll just write them out as x cubed. Then we have negative 2x squared and another negative 2x squared, which is negative 4x squared, okay? Negative 3x plus 4x is a just 1x, or just positive x, and then plus 6. And that's everything put together that I can. Okay? Oh, shoot. And I don't remember. I don't have my calculator here to do this next one. Anyway, 37. We'll try it and see. We have things that are to the second power, and we have to distribute that second power through, and we also have to do that for the fourth power, okay? So 3 squared is going to be 9. A squared is just a squared. So we have that. That's that simplified. Now, 7 to the fourth power is, I got to remember, 2401, I think, something like that. Let me check that. 2401, and that's b to the fourth power, okay? So 7 to the fourth power means 7 times 7 times 7 times 7, and this is 49, and this is another 49, and we take 49 times 49, oh heavens, 81, 9 times 4 is 36, so 44, 6, 3, 1, 9, 1, 0, carry the 1, 4. Yeah, 2401, perfect. 2401, okay? And now we want to put those together. So we still have to multiply the 2401 by 9 now. Okay, so I'm going to take that times 9. This is the way you do it before calculators, right? I don't know if we even remember that. 9 times 1 is 9. 9 times 0 is 0. 9 times 4 is 36. Carry the 3. 9 times 2 is 18, 19, 20, 21. 21609. 21609. And then we combine the a's and the b's. So a squared b to the 4th power. Okay. At this point, like if we would have another a, like let's say we had a to the 3rd, at this point we would add those exponents, right? So that would be a to the 5th total. But there's no a's, so just a squared b to the 4th at the end. Okay. All right, 38, we're getting close. This one is another subtract one. So we have to distribute the negative. For each of the back pieces, so negative 4x squared, that's going to turn to plus 7x, and then minus 1. So we got 2x squared plus 3x minus 4. And we're just going to combine like terms. So 2x squared minus 4x squared is negative 2x squared, gone, gone. 3x plus 7x is plus 10x, gone, gone. And negative 4 minus 1 is negative 5, so there he is, okay? All right, 39, we're getting close to the end. 39, we have two questions that they're asking. They're saying, is this function that we have shown right here, is this an odd function or an even function? Like they're talking about the degree, like the exponent. Is this odd or even? And then we have to decide, is this a positive exponent or is it a positive polynomial or is it a negative polynomial? Okay. So this one, since it's going opposite directions, like one side's going this way, one side's going this way, this is going to be an odd function. Odd means opposite. Okay, an even function, like let's say x squared is an even function. Even. X squared is a parabola. They're both going the same direction, right? They're both going either up, or if this is a negative x squared, then it's going down, right? So that's how that works, okay? This guy kind of looks like he's an x to the 3rd power function, which is an odd function, okay? And he's going opposite directions. That means he's odd. And the fact that up here we're starting and then we're ending down here, we go from left to right, it's going downhill in the general direction, that's what makes him negative. So this is actually the graph of negative x to the 3rd power. A positive x to the 3rd power would look something like this, right? Because he's going in the general uphill direction from left to right, okay? So this is opposite, or this is odd and negative because it's opposite and going downhill, okay? So hopefully that made sense to you. This is all of the different combinations that you could have. Even, odd, and then positive, negative, okay? All right. Let's move on to the last one, number 40. Identify the leading coefficient. So we need that. Whoop. Leading coefficient, degree, and then it says end behavior. Okay. The end behavior is as x goes to infinity, what's the y doing? As x goes to negative infinity, what's the y doing? That's the end behavior that we need to find. Okay. So, and the end behavior is based upon what the degree and the leading coefficient are, okay? So the degree is not always the first exponent that you see. It is the highest one. So we have like 6 is an exponent here. This is 3. This is an exponent of 1, okay? So we go with the highest one, which is 6, okay? And then the leading coefficient is the number that's in front of the highest exponent. So since we chose 6 to be the highest one, negative 3 is the leading coefficient, okay? And now we look at, it kind of goes back to like this stuff up here, whether it's even and odd or positive and negative. So the degree was 6, and that is an even, okay? So it is going to go the same direction. It's either going to go both up and up or down and down, okay? And the reason, or the decision we have to make is for up and down is it positive or negative? And it's a negative 3, which means it's going down and down. So it's going to look something like this. I don't know how many humps it has in the middle of it. That's what it probably looks maybe something like, maybe it only has one hump in the middle. We don't know. But we really don't care. We just are looking at the end behavior. So what's happening on the ends. So as x goes to the right, on the right side over here, it's going down. So it's going to our negative infinity. As x goes to the left, it's over here, and it's also going down, so going toward negative infinity, okay? So there is that. That is the rest of the review. I would really advise you to maybe look this review over again and try to do some of these problems again, just to make sure that you've got them down before we take this test on Monday. You're taking this test on Monday. Do some of these again. Look over the ones that you might struggle with. Come ask me questions if you have them. That is a-okay. But you can use this review on your test, but make sure you study and make sure you know what's on this review, and you will be good to go. Okay?